Welcome students to our today's lesson. Today we are going to learn about the hyperbola, and the hyperbola is a little bit similar to the parabola, only that in this case you will be given some ratios. So a hyperbola, it is the locus of a point. So once you get this term, the locus of a point, it simply means that this is the focal length, the locus of a point in which moves so as to be at a distance from a fixed point. These are the key ones. In a ratio, so I said for a hyperbola you will be given a ratio that it is from a fixed line. So what does it mean? So for I know for a hyperbola we just do the directrix like this. We say this is the directrix, and we go to draw our smooth curve. So for this case you have been given the eccentricity. This is the ratio. We normally call it the eccentricity of 2 is to 3. And we have some variables over here whereby we label this one as C, which is at the beginning, at this junction. Then we had our F, which is the focal length. Then again we had our V. So that is V, and you know that V, that is where it is the turning point of our hyperbola. So now, when you have been given the eccentricity, which is now the ratio, this one, you have been given for this case as 2 all over 3. So how do you get to elaborate this eccentricity? To elaborate this eccentricity, for instance, at the top you have been given 2, and at the bottom you have been given 3. So 2 represents this distance from F to V. So it is in this ratio. So VF all over 3 represents this distance in between C and V. So it is VF all over CV. V, like that. Even if you have been given any kind of a value in terms of eccentricity, like for instance, if it could be something like 3 all over 2, it means that 3 represents this distance in between V and F, and while 2 represents the distance in between C and V. So it is VF all over CV. So this is the formula that you need to recall all the time. So that is how you get to elaborate the eccentricity. This one given by 2 all over 3, whereby 2 represents this part from the V up to F, while 3 represents the distance in between C and V. So those are very important terminologies. So now, whatever you will do, for instance, you have been given the distance between the directrix. This one, we call this one the directrix, while this is your axis. That is your axis. So where do you begin? So first of all, you have been given the distance in between C and F, whereby C and F, it is the distance is in between the directrix and the focal length. You have been given the distance as 50 millimeters, like that. So now, whatever you do, you need to subdivide this line again using the method that we have been using. And how do you get to determine the number of portions that you need now to subdivide this line? Remember, for the parabola, we do not have definite number of points that we need to mark this particular line. Like for instance, we just marked 2 of them. So for this case, if you have been given the eccentricity, this one, as 2 all over 3, you need to add 2 plus 3 to get the total. Hope you are getting. So when you add 2 plus 3, you will simply get 5. So what does that one tell you? It tells you that you need to subdivide this line, which is line CF, which is the distance in between. We call this one as the we named it as the eccentricity, while this is the focal length. So the distance in between the directrix and the focal length, we said it is 50. This distance is 50. It is 50 millimeters. So now we need to subdivide this line in between C and F into 5 portions. In this manner, ordinarily we have been drawing a line at any given angle. Let it be not that much, the angle should not be that much large, just have an average angle. Then from there, with your pair of compass, you should subdivide this line into 5 parts, like 1, 2, 3, 4, 5, like that. Then the last point, you join it to this part. Then from there, we draw lines that are parallel to this line, the line using your set squares like this. So now you can see that you have subdivided this line into 5 equal parts, and whatever has guided you into the subdivisions of this line, it is this eccentricity, whereby you need to add 2 plus 3 to get the total, which is 5. So again, I said that because it is a ratio, since it is a ratio and you have been given 2 all over 3, I said 2 represents the distance in between F and V. F and V, and the distance in between F and V, for instance, you have been given it is 2 units. So you will count 1, 2. This is, for instance, let's just name them 1, 2, 3. This is 3, 4, 5. If that is how they look like, so 2 portions. Let's start with this one, 2. So we have 1, 2. This is where you are. This is now the division, the line that is dividing. We have 3. So it will be, we said 3 represents the distance between C and F. So we have 1, 2, 3. So that is it. Now whatever is remaining is to draw vertical lines starting from V all the way. You can draw several of them. Then with the pair of compass, you take this distance, transfer it to this other. The axis, the line x-axis. Just mark all over using the same distance. So stepping here, mark like this. Then from there protrude other vertical lines like that. So that is it. Now from there you will take your compass, then measure this distance, this one, the line that is demarcating this ratio, the ratio of 2:3. Then using that distance up to where you have your point F, you should mark at the top. Stepping here, you'll mark at the top like that. Then all the time you should be using the focal length as the stepping point. So after now you mark here, you will now go to the other lines as you proceed in marking. So and before you do that, you will draw a line that is starting from C up to this point. like this. Hope you have seen. Then from there, you now take your compass, then measure this distance with your compass, then step at the focal length, put a mark. And let's now get to see the procedure clearly by the construction now. So in that particular question that we were handling, we had been given the distance between the directrix to focal length. We had been given 50 millimeters. Then we had been given the eccentricity as 2/3. Those are the key things that you need in that particular question. So now, let's begin. First of all, we have to start with the directrix. Start with the directrix. So this is the directrix. Then this is your horizontal line, which is the x-axis. This one. So now, whatever you need to do is first of all to locate the distance in between the directrix and the focal length. So we need to identify that distance. Then from there, with the end of your compass, you should measure 50 millimeters. 50 millimeters divided by 10 to convert to centimeters, you'll get 5 centimeters. So into your case, you should measure 5 centimeters. Should measure 5 centimeters. That is my 5 centimeters. Then the distance, we sent the distance in between the directrix up to where you have your focal length. It is the 50 millimeters. So this is the focal length, which is F. That one abbreviates the focal length. This one abbreviates the center of curvature. Now, this is the 50 millimeters from C to F. It is 50 millimeters. Then you have been given the eccentricity as 2/3. I said initially you need to add this eccentricity. So 2 plus 3, you will get 5. 2 plus 3, you will get 5. That means you need to subdivide this line into 5 equal parts. like that. Then from there now, with the end of your compass, step at C, then mark 1, 2, 3, 4, 5. Then the last point, like we have been doing, you join it to F. Like that. Then now you draw lines that are parallel to this line using your set squares. And you need to hold your set squares very carefully. Like this. Then now you slide like this. So that is how you get subdivide a line into equal parts. Let me bold this. That is your 50 millimeters. Then we have the 5 divisions. Then, if you have been given the eccentricity as 2/3, it means that you shouldn't count starting from point F. Like for instance, we have got 5 sections. We have 1, we have 2, we have 3, we have 4, then 5. Hope you can see. They are 5 in number. Now you need to count starting from point F. So it will be 1, 2. So at this point we have counted 1, 2. This is whereby you have your V. You can place it below here. This is your V. Then from V you will count 3 sections. This one, we are through with this one. We are at this one. So we have 1, 2, 3. So you can see now we have the ratio of 2:3, whereby we have 1, 2, then 1, 2, 3. So it is in this ratio 2 all over 3. 2 represents VF all over, then 3 represents this one. 3 represents the distance between C and V, like that. So this is whereby you have your V. Your V is in between these two ratios. The ratio of 2 is to 3. At this point, that is where you'll be having your V. Now from there, you need to draw vertical lines . From there, you can take up your compass and draw several lines using this distance. Those are enough. Then now, hope you are noticing this. I need now to take this distance, the distance V, F. So I will step at V up to where I have my F, like this. Like this. So you can see that it is exactly at V, F. Then stepping at this. Then stepping at V, stepping at V now. It is exactly now VF. I should mark at the top. Then now with the end of my ruler, should draw a line like this. So it is like that. Then from there now, I will be using my compass to transfer some measurements over here. So I want you to take to note this. So I should just place my compass at any given point, then adjust to this line that I've drawn over here. And all the time I should be stepping at F to make my axe or my marks. So let's begin with V, this point. Like this. Then now I should step at point F. The mark. It is exactly at, now I'm exactly at point F. I don't need to transfer the compass now. Then from there, then transfer to F, mark like that, then to this one, then now step at F, put a mark, like that. Then these marks, they should coincide up and down. So again, go back. Measure from here, take there. They should coincide up and down. So let's mark for this side. Go to this one. At this one we stepped at. He's having a problem. This one. Then downwards. Then from there, this one. It is already at F, I don't need to transfer. From there, this one. And then transfer to F. Mark below. Then from there, the last one. Transfer to F. It is okay. Which point is it that we have not marked? Let's try V. Then to F. It is now fine. It is now fine. Then again V. So you can see it has marked at this line at this given point. Then now whatever is remaining is to join the point with a very smooth curve. Like this. So that is how it looks like. So you just need to join those points in that manner, and that is how we get to construct it before we get to the summary. So this is the curve that we are interested in. So this is your hyperbola. This is your hyperbola. And I think, let me give you a summary, a little bit of what I've done. So first of all, started with this is what I did to come up with such kind of a diagram. Started with this line. We started with the directrix and the axis line, which is the x-axis. Then from there, we said this is the center of curvature, which is C, and we said that the distance between C, which is the directrix, and where we have our focus is 50, should measure 50. We measured 50. Said this is now 50. This is your focal length. We have been given the eccentricity as 2/3, whereby we said that you should count starting from the top, from this side towards this direction. So we have to divide this line into 5 sections, whereby we said you need to add 2 plus 3 to get 5. Divide a line, we said you need to protrude another line at any given angle. Then subdivide this. 1, 2, 3, 4, 5. Then join the last point, which is this one, up to here. Then use your set squares. Like this. So that is how we subdivided the line. This is the focal length. We said we should count the eccentricity from this side, so it is, we have 1, 2, 3, 4, 5. So we have 2 sections from this side, so we have 1, 2. This is where you have your V. Then we have 3, so we have 1, 2, 3. So it is very okay. Then from there, we drew vertical lines. So these are the lines that we drew. Then from there, we took the distance from V to F. This distance, V to F. Then we marked at the top. I call it B. So B, V is equal to V, F. So you can see the way I've transferred this same distance. I've placed my canvas, then marked. From there, took my ruler. And protruded this line in between, passing from point C up to where you have your B, or not like this. Then from there I need to extrapolate some other points. I should use the same measurements. I can extend so that is what I did. Then from there, you can continue 6, 7, 8. From there now, we should take these measurements, like I was doing. Should start with this point. This point. Then transfer mine. You can see it is adjacent to point V, B. Then now transfer my canvas. Always I should be stepping at, so always step at F. So you can see like this, I've just taken the measurements, then transferred to F. Like this. Proceed to this one. I've taken the measurements, then I've moved to F, marked below. Then from there, take the measurements of this one from point F up to where we have this line. And because we are already at point F, we don't need to transfer the canvas to anywhere. So you just need to put marks up and down. Then from there, proceed to point 6. Take the measurements like this. Then transfer to F. Put a mark. Put another mark. From there, we go to 7. Then shift to F. Put a mark, put another mark. So I think those are enough. Now from there, you need to join those points with a very, you can see the points here, like this. The very smooth curve. So generally, this is the curve that we are interested in, and we called that curve the hyperbola. So this is our hyperbola, and in your hyperbola, both the construction of the hyperbola and parabola, in these constructions, the turning points should be at V. So this should be the turning point. So when you are beginning, you need to start by taking these measurements in, starting from this point V up to where you put this mark. From there, you shift to F. Start with the first mark, whereby we marked from point V to F. Then from there we proceeded like this and like that. So this is our hyperbola. So thank you so much, students. get to use this same procedure. Copy the question that I've given you, and on your own get to draw this hyperbola and ensure that it is very perfect from your side. So thank you so much. Let's meet in our next lesson. Stop. Sitajua hapo mwenye nilianza kutembea.
Yeah.
Imeenda ngapi?
You know ile nilikuwa nimekuongezea 8 minutes. So ilishaisha.
Nikana mjui
hapa. Inafaa isha saa 8:53.
Sasa ni ngapi?
Na 57.
Sasa hivyo nimekula dakika 4.
Yeah, but si